Okay, so for my project, I did exponential equations. So first of all, I'll just show you how an exponential is written. It's f of x b to the power of x. There are two types of exponentials, either exponential growth, which is on the left, or exponential decay, which is on the right. In exponential growth, b is bigger than 1, and in exponential decay, b is less than 1. So now here are some equations where you could see an exponential being used. The first one is just standard equation. And then next we have some more specific ones. The top one is a quarterly equation. The bottom one that's about to be written is the continuous equation. T is time measured in years, A is balance, P is starting point, and R is the rate of investment. And so these equations are both exponentials, and they help you with answering questions about banking and investment. So if you're going to talk about exponentials, you have to talk about logs. So this is the standard form for a log. Y equals log base b x. ln is the natural log, which will come in handy later, and 10 is the common log. So since these are inverses, it's very easy to convert from one each other and use them to help solve other types of equations. So you could go from y equals log base b x, or b to the power of y equals x. So now here's an example for you to try out, and you can be filling all this in on the note sheet. 3 equals log base 7. If you change that into an exponential, you will get 7 to the power of 3 equals x. Here are some log rules, which will also help you solve these types of problems. So the first one is the product rule, which basically just says if you have two logs being added together, in this case the m and the n would then be multiplied. Quotient rule is very similar to that. If you have two logs being subtracted from each other, the m and the n in this case would be divided by each other, and those would be represented by real number values in an equation. And then lastly, there's the power rule, and there are more rules, but these are the most helpful, which says that if you have a log base times m to the power of p, you can take that p to the front to make the whole equation way easier to solve. And you can only do that, you can't do that for an exponential, you have to have a log in there. And on the bottom I just wrote some tips for you to remember when trying to solve these equations. Okay, so now we're going to solve this exponential. E to the power of 2x minus 2e to the power of x minus 3 equals 0. So the first thing you have to do is you have to factor this problem. So once you factor that, set them equal to 0, and then I individually in my head set them equal to 0 and then tried to solve for x as much as I could, but then you got stuck here when it was e to the power of x. How do you solve for the x? Well, here you would use a natural log. So if you put ln on both sides of the equal sign, which I will add in after this step, ln and exponentials again, natural log and exponentials are inverses, so those cancel out. So then once you cancel those out, you're left with x equals ln 3 and x equals ln negative 1. So what you would do at this step is plug this into your calculator. But from the first one, you know that you can't take a log of a negative number, so that's an extraneous solution. So then you're just left with x equals ln 3. And then once you plug that into the calculator, you get a simple answer of 1.10. And that is the answer to this question. This is a second example of an exponential. 5 to the power of x minus 3 equals 137. And to answer this question, you would also use a natural log. So you plug ln to both sides of the equation. So now from this point, you can use the power rule. And if you use the power rule, you bring x minus 3 into the front of the equation. And then after that, you must distribute the x minus 3. And then from here, it's just simplifying till you get to what x equals. So you add 3ln 5 to both sides of the equation, and then you divide both sides by natural log 5. The two natural log 5s cancel out, so you're left with ln 137 over natural log 5 plus 3. Plug that into the calculator, and you get x equals 6.06. Thanks for watching.